Hello everyone, this is Dr. R. Dilip, Assistant Professor, Department of Physics, Dr. N.G.P College of Arts and Science. Today we are going to discuss about productions of X-ray belongs to Medical Physics, Unit 1. In this video, we discuss about electromagnetic spectrum, discovery of X-ray, then how the X-ray is produced. So production of X-ray and properties of X-ray and some examples of X-rays. Okay. First, we need to discuss about the electromagnetic spectrum. So what is electromagnetic spectrum? The electromagnetic spectrum is nothing but is simply light. Okay. So in this electromagnetic spectrum consists electric field and magnetic field. The both field are perpendicular to each other. At same times, the amplitude of the each field will rise at the same time and zero at the same time. This is a simple condition for the electromagnetic spectrum. And the electromagnetic spectrum also propagate is perpendicular to both electric field and magnetic field. So here we can see the electric field belongs to the y-axis, then magnetic field belongs to the z-axis, and its propagation through the x-axis. So electric field and magnetic field both are perpendicular each other, then propagation is also perpendicular to the both the field. Okay, this is the electromagnetic spectrum. Okay, so the electromagnetic spectrum is nothing but this is simple form of the light. So okay, so here the wavelength of the electromagnetic wave means the here this start from this point to this point. In this between the gap, the crust and tuft. So one crust and one tuft is equal to the one wavelength. So this wavelength is generally we can denote it as lambda. Okay. So lambda is the wavelength of the electromagnetic spectrum. So here the wavelength is an important factor because the wavelength is minimum means it behaves as somewhat different, and the wavelength is will increase means the properties of the electromagnetic spectrum is differ. So how it differ and how it is what's the properties and how the energy will become as when wavelength is shorter means how far the energy is exits, and how far the properties will exist, and when the wavelength is maximum means how far the energy and what do you mean energy and properties are very different. So wavelength is an important factor in electromagnetic spectrum because the wavelength is deciding factor whether the harmful radiations or that is non-harmful radiation. So in this slide you can see the wavelength is minimum means it will comes under the gamma rays, X-ray, ultraviolet ray. Then the visible range is from 350 nanometer to 750 nanometer. So after that, in the range of 100 nanometer to 1 centimeter, it becomes infrared, and after more than the wavelength, more than 1 centimeter, it becomes radio waves, TV, FM, like that. But the waves are same, but the wavelength only here change. When wavelength is increased, the energy will decreases. Then wavelength will decreases, the energy will increases. So these three, what do you mean that? These three gamma rays, X-ray, ultraviolet rays becomes somewhat harmful effect. Why it becomes harmful effect? I will explain you later. Just note it down. Okay. Then here we see that WebGR, so each color have a different wavelength, and we know that this visible light region from 350 nanometer to 750 nanometer, and So I already told you that the radiation behind radio, visible light, and nuclear buster is all exit same thing, but the difference is only depends upon the wavelength. So higher wavelength, it comes under longer wavelength, longer energy, lower energy, and lower frequency. Okay, the shorter wavelength becomes higher energy, higher frequency. So in these shorter wavelength, this belongs to the gamma rays, X-ray, and ultraviolet ray. So why it becomes harmful? So first of all, we need to discuss about that. So because these shorter wavelength, these three rays or get ionization process, it can create the ionization. So what is mean by the ionization means the removal of electrons. Okay, so okay sir, we simply it remove the electron only. What is the big defects it will create? That means the electron is a major part to decide the factor, the characterization properties of atom and molecules. So once they lose the electron means the entire characterization properties of the atom and molecule it can change. So it causes the cancer, then skin disease, like that. So these three ways are very harmful to all living beings, not only for human. All living beings, it will very harmful. So only it will become the harmful. Then after that, when we increase the wavelength, then it becomes the visible light and infrared, and microwave radios are non-harmful effect because it not produce the ionization process. Okay, so I hope you got somewhat clear idea about the electromagnetic spectrum and what is the wavelength and how the wavelength impacts the characterization and energy of the radius. Okay, then next we going to see about the discovery of X-ray. So W.C. Röntgen, the German physicist who discovered the X-ray on November 8, 1895, he termed the ray, he can't identify the ray. Somewhat the rays is came out from his experiment. So he simply fixed as he unknown the ray means. So he simply fixed as X. X means in mathematical symbol unknown means. So he found the unknown rays. So called he fixed as the X-ray. Then he received the Nobel Prize in 1901 due to his invention. Then now let's come to see about the productions of X-ray. In productions of X-ray, we need a simple setup. We need a Coolidge tube, vacuum Coolidge tube, and one copper anode and one cathode filament, heated tungsten filament cathode we need, and these both are connected with the high voltage source. Okay, this once the high voltage source is applied, the electrons, the filament, heated tungsten filament get heated, and a high potential electron will eject from this source. Then this electron will hit the target, tungsten target, then X-ray will produce. Then here we can use the high voltage means 1 megahertz to 1 kilohertz to 1 megahertz volts. Okay, so here the electrons will hit the target and produce the X-ray. So okay sir, how it is produced in this process, how it can produce the X-rays, particular X-rays, we can see in next slide. Okay, here this is the atom of tungsten. Can you imagine that this is the atom of tungsten means this is a nuclear, and the around the electrons are revolves around the nucleus. So this is K shell, M shell, sorry, K shell, L shell, and M shell. So here we the incident electron. So high potential incidence electron hit the K shell orbital photoelectrons. Okay, it can remove. So this is called as the ionization. Already I told that what is the ionization process is it will remove the removal of electron. That's the ionization process. So here this high potential electron is hit the K shell electron. It will ejected from here. Then after that it will the vacuums will create. These vacuums we called as generally called as hole. Okay. Here these vacuums will occupy by the higher energy electron from L shell and M shell, either L shell or M shell. So if the electron is occupied from higher orbit to lower orbit, it will emit some energies. That energy is called X-rays. Okay, here the graph will shows when the electron is occupied from L means the energy level is very high. Then the electron is occupied by from M shell means the energy level is somewhat low, but it also produces the less power of the X-ray. The energy potential level is somewhat less than when compared to the L shell. So I hope you can understand what is the X-ray, how it is produced. Okay, this is the main and basic idea of productions of X-ray. Then somewhat we know that some properties, some main properties of X-ray. So X-rays travels in straight line only. X-ray cannot be deflected by electric and magnetic field. X-ray have a high penetrating power. Then photographic film is blocked by the X-ray, and fluorescent metal glow when X-ray or directly hit them. Then photoelectric emission can be produced by the X-ray. Then ionization of gas, I already told you that there is gamma rays, X-ray and ultraviolet can make the ionization process. The removal of electron process it will make that. So the ionization of gas result when an X-ray beam is passes through it. Then some of the applications of X-ray. We know the applications of X-ray means at time we, our thought becomes that what is the in medicals when the some of get bone is broken means the doctor suggested to take the X-ray report. So that's the main thing. But apart from that, there are so many things. The applications of X-rays. So there is a differentiation between crystalline and amorphous material. It can help to and it can to determine the structure of the crystalline material, determination of electron distribution within the atoms, and determination to orientation of single crystals, and to determine the polygrains materials, then the measurement of the stress and strain of the small size grain. There are so many examples is there, but generally we know the X-rays are commonly used for the mostly used for in medical terms, and apart from that also there are so many applications exist. So what W. Ranjan got the Nobel Prize in 1901. So summary of we comes to the end of the section. So summary of this video, and I hope you all get some of basics idea about the EM wave. EM wave is nothing but electromagnetic wave. Electromagnetic wave is nothing but the light. Okay. Then productions of X-ray, we use the X-ray tube, that's the Coolidge tube, and how it is produced, and what are the properties of the X-ray, and their application we saw at the end of the video. Okay, thank you for watching this video. Thank you so much.